Okay, so I have Isaac here with me from the Need Water team. Isaac, do you want to tell us a little bit about what you've been working on?
Sure. Um, so since the Extreme Affordability class ended, we were given some specifications by our partner they would like our design to meet, and if we manage to meet those specifications, they will move forward with a in-field durability test and user test for further refinement and possible integration in their next year's product portfolio. So what we've been up to are trying to meet a flow rate specification of somewhere around 800 gallons per hour for the pump, which is the baseline of the current product. The prototype, as you might imagine, leaks a little bit, and so has a little bit lower flow rate because it doesn't pump. Part of what it pumps goes back down the inlet. The other specification we've been trying to hit this summer was being able to prime the pump from a well. So that basically translates into what's called suction head. So we need to be able to suck water up from the bottom of the well at least 15 feet below the pump itself in order to prime. So we've gone through a couple prototype iterations, which you can see here. This is our testing platform, which is a modified pump by our partner that we modified. And the first thing we did was we set out to increase the flow rate of our prototype from around 250 gallons per hour up closer to 800. As you can see here with this sleeve, which was part of the prototype that we came out at the end of the class, these are the ports through which some of the water flows coming into the valve and going out of the valve. But they only go about a third of the way around the valve, and so the flow was fairly choked. So one of the first things we did was open those up all the way around to increase our port size. Increasing the port size led to this prototype, which basically has these plates here that allow the valve to collect water from 360 degrees around the valve rather than just the top and bottom as you saw in that sleeve. So this is actually the current prototype, and with the modifications we were able to bring the flow rate from 250 gallons per hour up to around 600 gallons per hour, which is on par with the specification that our partner asked us to meet.
Cool. So what's next for you guys?
The next step for us is to work on the other specification, which is priming in the air state, so sucking that water up from the bottom of the well the first time. Some of the challenges that we are facing are the fact that we have a sliding seal inside, and there's a balance there between if you make it a real tight fit, you'll get a very good seal, but you'll have high sliding friction. And since the valve is actuated by the air and water itself, there's an upper threshold on how high that sliding friction can be before it just stops moving or gets jammed. So we're trying to find that balance a little bit better. But the real next step that we've come across is moving away from a design that requires precision. So we've been using O-rings, which are made to be fairly rigid so that they can maintain pressure differentials of thousands of psi. But since the barrel of the valve is quite imprecise, we have to make a sealing system that's more flexible to ride over the bumps and the troughs without losing its seal. So our next prototype will be one made out of silicone instead of the harder rubbers used for O-rings. And we also hope to, with that prototype, eliminate sometimes when the valve slides back and forth, the O-rings will slip out of their grooves, and our solution so far has been to super glue them in, but right now in the next prototype, since we're casting them out of silicone, we'll be integrating it with the sleeve that goes around the valve so that they are attached to the valve itself.
Awesome. Anything that in particular that you might need help with or be looking for?
Yeah, we're always looking for people that might have expertise in sliding seal design, particularly with how to optimize that balance between a good seal and low sliding friction, as well as that would be the main thing.
Cool.
Expertise is really what we're looking
Looking
for
for.
at the moment. Yeah.
Awesome. Cool. Thanks, Isaac.
Uh-huh.
Good luck.